afternoon, everyone. GM, thank you so much for coming here and for joining us this afternoon. We are gonna have a very, very packed afternoon. I want to introduce myself. I'm Patricia. I'm from OpenGuild. So we are a developer community focused in Southeast Asia. All our resources are open, so anyone can access that. If you want to learn Polkadot, we structured all our open source from all the technical writers in the Polkadot ecosystem, just the way how we think you would learn Polkadot if you are going to, check it out. But anyway, so for this afternoon, just a few, housekeeping. I really encourage you to put your attention to the speaker, to the panels. It's gonna be a very interesting one. So for today, we're gonna have two keynote speeches and two panels. So one would be about, of course, our ecosystem winning the scalability wars, and then second, later in the afternoon, would be about the AI. But in between of the program, we're gonna have a coffee break. So please stay in your seats. But of course, if you need to go to the restroom, you can use the break later on. To introduce our first speaker, Tommy. Tommy is an active contributor in the Polkadot ecosystem for about 3 years now, I believe. Yes, and he's leading mostly the OpenGov Watch. So OpenGov Watch is acting like a police in the open treasury of Polkadot treasury. I think it's very important because he needs to make sure that what you promised, what you propose, is you're doing it. You have to do what you promise, right, Tommy? Anyway, more than that, I will not take it long. I will have Tommy introduce himself. So, are you ready, Tommy?
Yes.
Take it away.
Okay. Apparently, I'm undercover police. Okay. So, good morning, everyone. People typically say, but it's afternoon. And then I respond, but it's always a good morning in Web3. So, on January 3rd, 2009, The Times was posting the headline, Chancellor on brink of second bailout for banks. We know this. It made one guy very angry, Satoshi Nakamoto. And he has been building something for quite some time. And so this was quite a coincidence because 6 days later, he launched the Bitcoin blockchain. And the basic question that he has been answering was a question that has been asked for, I think, 10, 20 years at the time. So in the 90s, people were already thinking about how you could build such a system. Like they didn't have a clear understanding, but they have this rough idea. And so today we can phrase the question as, can we create a distributed ledger that cannot be manipulated by a single party, right? Bitcoin, as we have it today. And he even embedded this message, Chancellor on brink of second bailout for banks, into the first Genesis block of Bitcoin. So the resulting thing that we have is distributed ledger technology. And we tend to think about this when we hear the word ledger, but that's actually not the case. So if you're not a native English speaker like me, you might have to look up what ledger actually means. But ledgers are these main books of any business where you basically put in every Bitcoin transaction or financial transaction. So sometimes when I'm explaining Bitcoin to people that come from finance, I basically say a Bitcoin block is one page in a ledger, and the Bitcoin blockchain is this full ledger. Now, this ledger is very simple because you do simple addition and subtraction. So you can liken Bitcoin to a calculator. It's just a thing where you shift numbers around. Now, in the same year, on April 14th, in World of Warcraft, the Warlock was nerfed. He had a siphon spell, and this made one guy very angry, which was Vitalik Buterin. And he is quoted as saying, "I cried myself to sleep, and on that day I realized what horrors centralized services can bring." I too like to play games, but I've never been so invested into a single character. But on a certain level, I can relate to Vitalik. But it spawned something very beautiful. because Vitalik, a few years later, has been answering the question of, can we create a virtual machine on top of a distributed ledger? And so we went from a calculator to a computer. Ethereum is a computer. And I think it's very important to make this simplification, because it's already hard enough to explain Web3 and crypto and all of these things to people. So I always go to this realization first: Ethereum is a computer, because that makes the rest of the conversation much easier. So we had the question of, can we build a distributed ledger? And then we had the second question of, can we build a decentralized computer? And today we understand these questions as the first and second generation of blockchain technology. So the first generation has been asking the question, can we build a distributed ledger? And we got Bitcoin, we got Monero, Litecoin, those things, right? So basically like simple calculators. And then the second generation was asking the question, can we build a computer? And so we got Ethereum from that, we have Cardano from that, and quite a few other chains. And now the question is, what is the third generation of blockchain technology? And the main question I believe that the third generation of blockchain technology is asking is, how can we scale? So with that opening, I would like to welcome you. My name is Tommy. On Twitter and everywhere else, I'm known as Edison Bob. So feel free to follow me on Twitter. And this is also where you can reach out on Telegram. And sometimes I make YouTube videos, not so much today. So we will look a little bit into this question. And this question has been bothering us now since 2014, I believe, Ethereum launched. So this is 10 years now. We're in the 11th year. And basically for the last 10 years, we've been asking, how can we scale crypto and Web3? So the problem is Ethereum by itself does not scale. So it's a fantastic computer and it has all the network effects right now. But the maximum transactions per second is actually 119. I don't think we ever reached it. And the data availability, so how much data you can pass through the system today, is 378 kilobytes per second, right? You couldn't watch a YouTube video on that. So over the last few years, over the last decade, we came up with a few different answers. And I'm gathering 4 answers for you here today. So Ethereum is following the roll-up roadmap, which basically says, let's put additional computers on top, and then they post a little bit of information of what they're doing to the Ethereum main chain, roll-ups. We have high-performance nodes. That's Solana's answer. And that is basically the answer. Let's just make the computers much stronger. Okay, you won't have maybe 100,000 or 1,000,000 computers participating in the network. Maybe it's 1,000 or less, or 100. But they are really, really strong. And so basically, this is how you can solve scalability. That's the idea. Now, Cosmos has the answer of, let's just make a federated network. We build different blockchains, and they are opening bridges to each other, and then they communicate. And Polkadot has the answer of saying, let's build a common shared tech stack on which everyone is building. We provide shared security. And then all these different parachains that we're having, they are renting the shared security. So each chain can scale in their own independent way, but they're all connected under one security umbrella. So we have 4 different answers. And of course, there's a lot of other ecosystems, right? But these are some of the prototypical answers. You basically build different nodes, or you connect them similar how Ethereum and Polkadot is doing it, or you just make the computers really strong. Now, none of these solutions are ideal, and all of them have trade-offs. And so let's look a little bit and understand the trade-offs. Now, Ethereum has the roll-up thesis, basically building layer 2s. So, and the basic problems we're having is all these layer 2s, they're inconsistent. They're building different standards, building different interoperability models, different ways of how you're representing EVM or any kind of other things. We have the problem of fragmentation of state. So in Ethereum, the beautiful thing is you can have Uniswap and you have Aave and you have all these different DeFi protocols together, and they can compose a transaction together in one block. And so you can do a lot of financial things. Now, if you separate it out into different blockchains and layer 2s, suddenly you have fragmentation. We have bad interoperability. And there is also the argument, if you try to solve everything with CK rollups, it's basically having a centralizing factor. Because in the end, you will have very few CK providers that can actually deliver the performance that is needed. And it's expensive. Okay, we have Solana. With Solana, we have the problem with centralizing. There is no data availability layer. And even if with all the performance we see in Solana, it doesn't scale enough, as you will see later when we look at our charts. Okay, with Cosmos, Cosmos is a good idea. Basically, everyone builds their chain and we connect to each other. But we have the same problem with fragmentation. It's insecure because you have very low shared, you don't have shared security. And so you have very low individual economic security. And because all of them are bridged, basically it's becoming dependent on the weakest link in the system. And building a chain is expensive. You need a team, and it's not just like maybe typically for a smart contract application, you could do it alone. You can have 2 people, 3 people. If you build a chain, you need people for DevOps. You need to run multiple test networks, live networks, and all that kinds of things. You need to have much more complex tokenomics. Okay, Parachains and the Polkadot model, we have similar problems. We have high economic security in Polkadot, but you still have a fragmentation across parachains, and it's still expensive to build, right? So we have these 4 different solutions. We're going to look a little bit into who is leading. Let's make a guess. And of course, we're picking our favorite graphics. So this is something that we in Polkadot are very proud of. This was in December 2024, where Polkadot broke a world record in terms of most transactions on a live network. If you're very fair, it's not Polkadot, it's Kusama, but they're technically the same, both are production networks, and we're gonna make the same proof on Polkadot. But it's the same technology, and it's the same live production environment variables, right? So 143,000 transactions per second, that was at 23% capacity. So if you scale it up to 100%, that would mean a theoretical maximum of 640,000 transactions that we're currently seeing. Second best is Internet Computer. If you look at Solana, they're at 2,900. They can maybe try to make a test run, but their theoretical maximum is 65,000, right? So even though Solana has mega beefy machines, their theoretical limit is below what Polkadot has shown in practice to be able to achieve. Similar for data availability. So Solana doesn't have data availability. Ethereum we see here fairly low. Polkadot right now has 42 megabytes per second. And that's more than the specific data availability layers like Celestial, for example, have, or Avail. And then one last one here. So even though Ethereum is very heavy on the layer 2 and rollup thesis, 10 of the rollups that are in the top 20 by transaction count, recently we made a measurement and 10 of them were Polkadot parachains, right? So even Ethereum that is focusing so heavy on layer 2, when you look at the top 20, we're beating them. So these are 3 very interesting stats that made me very proud recently, because I think what you see in many different crypto ecosystems is that they're on the defense. They have to defend their place. But these 3 statistics made me actually very proud recently of picking an ecosystem where the fundamentals actually pay off in the long term. Now, I'm gonna make this statement today that Polkadot leads in scalability. I challenge you to prove me wrong. We can have the discussion. But the fight is not over yet. So what you can derive a little bit from the discussion that we're having here is that winning the scalability wars is determined by 2 factors. First of all, who can process the most transactions, and who can do it in one shared state space, who can have one space where all of this is happening. Because the basic idea is having a lot of transaction throughput in a big state space is what creates network effects. Ethereum has the network effects because it has the network effects. There's a lot of capital, there's a lot of users, and this is why a lot of chains are building there. But what you also see, it's right now it's struggling. Just if you look at the sentiment, I look at Twitter, but if I look at the sentiment, if it's even in Ethereum, it's harsh right now. The only good sentiment I see right now is in Solana, and Solana is attacked from all sides for being just a meme coin chain, right? So basically everyone is in defense mode. And when we look at the fundamentals, we can look at these 2 parameters. Most transactions in one shared state. So I made this quadrant chart in the morning. We have many transactions, we have few transactions. We have a fragmented state, so lots of different chains, and we have a shared state. So we see the original Ethereum here. Low transactions, one shared state. Now they moved to this roll-up thesis, to the scaling thesis. And this basically means now they have more fragmented state, but they can have a higher transaction throughput. We have Solana here, which is like purely fragmented, but has like a fairly good transaction count. And then we have Solana with more transactions. Like they are pretty far high up right now, but I needed to leave some space. And then we have Polkadot right now, which in practice already showed that it can do more transactions, but it also has the problem of being fragmented, right? So there is like no one clear winner, right? The battle is still ongoing. And now when we come to the idea that it's basically a matter of trade-offs, and area of the ecosystems that we just looked at is making different trade-offs. The question we have to ask is, can we find the right trade-offs to win scalability? To win scalability. So basically we're looking for, can we build the thing that lives on the top right here, right? That it has one state and it is pure transactions. So, and this is where I'm going to introduce you to the idea of Jam, which we're building in Polkadot right now. So Jam is this design from Gavin Wood, where he basically asked the question of how can we solve this problem of having a fragmented state across different chains and still reap all the benefits that we have in Polkadot. And so the basic model we're building on Polkadot is that of a multi-core computer. So Ethereum is a single core computer. It has one thread on which it is running. Solana it has some kind of parallelization, but it's still one computer. It's still one virtual machine. The thing that we're enabling in Polkadot is having multiple different kinds of virtual machines, because there's always a need to have something of a unique character that has maybe a special value proposition. So we want to maintain this property of allowing you to create your own virtual machine if you want to. But at the same time, we want to make it simple that you can, if you just want to write a smart contract, it should be as easy as it is in Ethereum or everywhere else. So the basic idea of Jam, and I think this is going to be the least technical explanation you ever hear about Jam, because I'm not going to go into the details, but it's one shared high throughput environment. For any kind of roll-up or application, that can be a smart contract, it can be a parachain, it can be a Cosmos SDK chain, it can be an OpStack chain, it can be a CK rollup, it can be a Bitcoin UTXO. Any kind of roll-up or applications is supported. With a data availability of 850 megabytes per second on a 28-day rolling window. So this is data, this is like the RAM in your computer. It's the RAM in your computer, and it's going to be 8.6 petabytes that you could have access to if you write your application in Jam. So I think on this one, the core devs are actually conservative, because they're saying it's going to support 1 million transactions. If I just add up the numbers that I see right now, I get to 2 million transactions. But let's say it's going to support more than 1 million transactions per second. And I think we can be fairly confident on that, because our theoretical limit on Polkadot right now is 640,000. And I'm aware of so many different optimizations that core developers are currently working on. And so this is the only little bit tough one, but basically when you write a smart contract, it gets then interpreted by a program, and then it gets interpreted by another program, and then at the end it's sent to a CPU. Right? So it's a fairly in-performance system. Writing a Solana smart contract is in-performant. Also for all everything written in Rust right now that compiles to WASM. Now, we can make it more efficient if we make sure that we translate it as directly as possible to processor instructions. So this is why we're building it on RISC-V. And that means that we basically only have 50% overhead right now, which is fairly good in crypto, which means you can write an application and it runs almost as fast as if you would run it directly on your computer, but you run it on the blockchain. And Polkadot Jam is going to have 340 of those execution cores. So one of these execution cores is faster than this notebook. So it's basically one supercomputer of, I don't know how fast this notebook is, but like your regular computer is faster than your regular computer, because it lives in a server. So imagine stacking 340 of these notebooks together, and you can submit your application, and everyone can submit their application, and it's just processes that are running in this computer times 340, all working on the same problems, all creating one shared space of applications that are running together, which is so vastly different when you compare it with Ethereum, where we have like maybe 20, 30 transactions per second running right now. Vastly different, vastly different. So we're gonna make this proposition today that this is what we're building, Polkadot Jam, and it's gonna offer the possibility to run everything in a shared space. Or it's actually more technical, I'm simplifying here. But let's say it's like very close to having one shared state and also winning on transactions. So this is what we're building. And I'm very glad that you're coming here today to join us in this conversation. I think we're going to soon end the third generation of blockchains question with how can we scale? Because we have, how can we build a distributed ledger? The answer is Bitcoin. How can we build a decentralized computer? Ethereum. And how can we solve scalability? The answer is going to be Polkadot, right? And so we're moving from a calculator to a computer, and now the Polkadot cloud. And so this is why we're doing this major shift in our attention and focus on Polkadot, where we talk less about the technical details of how we build blockchain, and more about that we actually want to build cloud infrastructure. Similar to how Web 2 has been defined by Amazon Web Services, by Google Cloud, by Microsoft Azure, we're now looking at how can we position Polkadot to be the cloud of Web 3. And so we actually now can start to consider the question, what will be our question for the fourth generation of blockchain? And I suggest we find it out together. So thanks for joining us here today, and welcome to the Polkadot Cloud. Thank you.
Thank you so much, Tommy. Very insightful. Do you have any questions? Is there any questions from the crowd? Okay, we will take 2 questions only. Okay, here's the mic.
Oh, thank you. I think I saw on one of the thread on X talking about how the new Jam stack move away from block design, but like the transaction cycle just happens instead of like get chunked into block. Can you elaborate on that? Because that's the important part. Yeah, I guess interesting part.
Yeah. So the thing is, today you have blocks, right? So and Polkadot is continuing to have blocks, but what goes into a block in Polkadot is not going to be a single transaction anymore, but rather it's like a stream of data being validated. So we make the separation where we say, so this is actually for developers in the room, this is the most insane thing about Jam, is that we're going to transaction-less programming. So that means right now when you write a smart contract or you write a blockchain, you have to think inside the block. You have to make sure that everything executes within the transaction or within the block, and only as long as there is, you have to respect the gas limit, right? So in Polkadot, we want to think outside the block. And the idea is, if you have, how you traditionally learn to program is you don't think in transactions. You basically write the program and it just runs. And it can run 10 seconds or 10 minutes or 10 hours. When I'm training a neural network, I'm not doing it anymore, but when I did in the past, it was like running the whole night. You cannot do that on blockchain. Now, but with PVM and RISC-V, we can actually do it because we can just measure how long the program is running. And when we know it reaches the block limit of Polkadot, we just make a stop. We commit that execution to validation, and then we just let the program continue. We take another slice, send it to a core. We let it run. We take another slice, send it to a core. And so we separate out the execution, and you basically just have a program running. And as the developer, you don't care about like how long is a block or whatever. As long as you have the gas paid, it can run forever. If you want to have Game of Life or Doom, the game, run on chain, this is actually something that Parity is building right now as a proof of concept to show what Jam is capable of. They want to render Doom on chain, right? As an application that just keeps running indefinitely. So we're separating out the execution and don't care about the individual transactions anymore, right? These are just an implementation detail of how you write smart contracts. And we just have applications that produce work, and the work is being processed.
Okay, last one.
What applications are you most excited to see on Jam with the increase in throughput and computing power?
Yeah.
So like what new use cases do you envision?
I wanted to ask the same question Gavin Wood yesterday. I'm so most excited. What I would like to see as a first step, so I'm still lacking a little bit in imagination of what is all to come. What I would like to see for a start is basically applications that keep messaging each other. It's a little bit nerdy, boring answer. Actually, games. I would like to see games that are run on the blockchain and validated on the blockchain, and you don't even care about what do you run on the Web2 infrastructure because half the execution speed is pretty much fine, right? You have to see how much it costs, but I would like to see as a proof of concept to see of what we're capable to do, like game of life or some kind of interactive game being run, right? So I guess when there's going to be hackathons in the future, I very much hope that there is going to be a gaming hackathon specifically for chain.
Okay, that's
All right,
it. Thank
thank
you
you.
so much, Tommy. And another round of applause for Tommy. Thank you so much.